Hello, everyone. A very good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 7D. Myself, Anisha, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the Third World Conference on Information Systems for Business Management, ISBM 2024, Bangkok, Thailand. The third edition of the conference is being organized in a hybrid mode. The physical event is organized today in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th of September 2024. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. And on 10 minutes, I'll be raising a gentle reminder. There's also another request to all the participants that you all please stay connected with us till the closing of the session. And you have any update or query, you can write it to me in the chat box. So just before we start the session, I'd like to introduce you all to the chair for this session, Dr. Shailesh Pramod Bendale. He currently serves as the head of department and assistant professor at NBN Singhal School of Engineering, Pune, with over 12 years of academic and industrial experience. Dr. Bendale has contributed extensively to research in AI, cybersecurity, IoT, and software-defined networks with numerous publications and Best Papers awards. He is also recognized for guiding winning teams in prestigious hackathons like Smart India Hackathon and Ethereum ETH India 2023. So I welcome you to the session, sir.
Thank you, madam.
Okay, so yeah, we should begin with the papers now. And for the very first presenter is Gui Hang Fong with the paper title, An Implementation of Smart Home Surveillance System Using Internet of Things, IoT, and Machine Learning Model. Sir, do we have you here in the session?
Yes, I'm here.
Yeah, you may please start with your presentation.
Okay, may I share my presentation?
Sure.
Have you seen my presentation?
Yes, it's visible now.
Okay. So, hello everyone. Welcome to our research on an implementation of smart home surveillance system using Internet of Things and machine learning models. So, in brief, the development of home surveillance system has attracted more and more research in recent years. So the use of various machine learning models improve the ability of analysis of home surveillance system based on IoT system. So for presentation, I will divide my research into 5 different parts. Let's start with the introduction. So the home surveillance systems allow us to operate our daily life efficiently and remotely. With the advance of IoT technology, the development of home surveillance system become more and more popular. The IoT systems refer to the network that connects physical objects and virtual connection. In a system, we can use sensors and software to collect, examine, and analyze data. In the IoT system, physical objects can easily connect and transfer data. We collect a huge number of data in our home, and based on those collected data, we can analyze and provide the notification efficiently. So for the implementation of smart home surveillance system, we will analyze and provide the notification based on data collected from sensors and software in the system. Our input will be the data of home environment, which I will specify them later. After processing, the output will be home conditions prediction. And in case of abnormal values, our system will immediately inform users. Our system will improve the ability of analysis of home surveillance system. In recent year, before we start working on our project, we have some research about related work. Here are few of the previous work which we have reference to. So in brief, the combination of IoT and machine learning is an efficient solution to improve the security of industrial systems. So in our specific case, this is the system we propose. So uh, firstly, we will design the IoT modules based on the Arduino Mega board with sensors to collect data of home conditions. After collecting data, various machine learning models are fine-tuned to analyze and predict values. Finally, abnormal values are detected and notified to users for the security purposes, and the collected data and prediction results are exchanged using the Wi-Fi module of the circuit. Here's an overview of the home surveillance system. You can see that the sensor on the left will transmit the data to the machine learning model, and after it process and give out the prediction, it will like notify the users via cloud, and all the value will be displayed on a friendly user interface. It is the Arduino Mega board. The Arduino Mega board is like a brain of our system. We choose the Arduino Uno because it's suitable for both industrial and educational purposes. It also has a large community for supporting the coding, electronics, and data connections and abilities. This is like some information and some specification of the Arduino. So to collect home conditions, we design 5 sensors with the board, namely humidity sensor to monitor the humid status of the home, the light sensor to monitor the light status of the home, temperature sensors to measure the temperatures of the home, sound sensor to measure the sound volume, and finally the gas sensor to monitor if there are any gas in the home. This is extremely important to avoid the risk of fire. About the machine learning model, we apply and fine-tune the KNN, support vector machine, and neural networks to analyze collected data from the Arduino Uno board. The KNN is short for K nearest neighbors algorithm. These algorithms use the distance metrics to make classifications or predictions about the grouping of an individual data point. The support vector machine model applies the soft margin minimization for the prediction. So this is the image of the architecture of our neural network, which will include 3 layers. The first layer, the second layers, and the output layer. After the training process, we like specifically after 200 epochs, this is the value. This is the final result of our model. You can see that the training loss, the validation loss will drop significantly. So the prediction of the machine learning is divided into 3 categories: normal, high, and warning. After collecting data, we divide the data into training and testing set. The prediction of machine learning models are sent to the Arduino Uno R3, and the warning is notified to users when there exist abnormal cases. So this is some of the abnormal cases we prepare if there is any case of risk. Like first is the temperature is too high or increase quickly. Second is there exist gases in the home. The third is the volume of a sound be increased abnormally, and finally the abnormal conditions of humidity and light. So after that, we collect some promising results. So about the data set, we have total of 500 records of home condition, and we divide and we use 80% of them for training and the rest is utilized for testing the machine learning models. To evaluate the outcome of the algorithm, we use a accuracy metric. Accuracy is calculated by correct predictions over all predictions. For the machine learning models, namely KNN, support vector machine, and neural network, we achieve 93%, 94%, and 97% of accuracy, respectively. So, and below is the image of some data we collected from the sensors. After the results, we move on to the conclusion and some future improvement of our research. To conclude, presenting a home surveillance system using the IoT and machine learning models, that is what we acquired. Our system also can monitor home condition using the sensor, and the application of machine learning allows us to make decisions efficiently. The neural network gains the highest performance compared to KNN and support vector machine. Currently, we are planning some improvement for our project. Such as we will using more sensors to collect more data from home conditions, develop and deploy the system for large building, because currently our system is still at the experimenting phase. And finally, the security of the home surveillance system can be investigated and improved to support users more efficiently. So that is the end of my presentation. I thank you for your time, and I would like to receive question from you.
Thank you, sir, for such a nice presentation. One question from your presentation, that in your neural network which you train, you have used 40 parameters as input and 30 parameter as output. And while doing the analysis of your method, you have used three techniques. One is KNN, SVM, and neural network. So or have you performed the grouping like PCA on the 40 inputs that you have used for training your neural network?
Sorry, can you repeat your question? I didn't get that.
Okay, in short, I would like to ask you the 40 attributes which you use for training your neural network. Have you ran the PCA and have you identified the discrete inputs for your neural network model?
No, actually, I use the framework. I use a available framework on Python, which is called PyTorch, to feed our data in the network, and like the pre-built data, the pre-built framework, it will run the training process for me. So everything, let me review those presentation. So the input will come from these 5 sensors.
Yeah, that is fine. Just can you go to the slide number 14?
14, okay. Yeah.
Yeah, here you have mentioned that first layer will be of 40 and output will be of 33. So
Yes.
when you're considering this 40, have you done the analysis of the features which are present in this 40? Segregation of the values which you get in that 40 parameters.
Oh, about that 40. Wait, let me explain. So this is like the 40 parameters is like like
Okay, not an issue, sir. Because if you can segregate these 40 parameters for the different sensors that you have used, it will help you a lot in future also for your paper. That was a suggestion from my side. Thank you.
Okay, thank you for your suggestion. So, do you have any other question?
No, sir. Thank you.
Okay, thank you.
Thank you for the presentation. I just have one query. Can you please confirm your name? I guess you're the co-author of the paper, right?
Yeah, I am the author number 3 in the research.
Right. So the main author isn't present in the session, right?
Yes.
Okay,
I'm
got it.
yeah.
Okay. Okay, so moving on to the next presentation. We have Deepal Doshi with the paper title Debt Before Degrees, Analyzing the Student Loan Crisis in Higher Education.
Yeah.
Ma'am Deepal,
Sarah.
yeah, you may
Yeah,
begin
here
with your
I am.
paper.
Yeah, can I share my screen then?
Sure, yeah. Well, I don't see her in the session. So as we have time constraints, we'll be moving forward to the next one. Next up, we have Glacerio with the paper title Decentralized Water Consumption Tracking, a Blockchain Approach.
Hello, everyone. Are you hearing me?
Yes, sir, you're audible. You may begin with
Okay.
your paper.
Thank you. Can you see my screen now?
Yes, it's visible.
Okay. So good day, everyone. This is Glicerio Bagia, presently connected with Cebu Technological University of the Philippines, particularly at Hinatilan Extension Campus. Emerging technologies has always been fascinating for me. So today, allow me to share with you the results of the study that I have been working on the past couple of months. CTU BSIT students developed and launched the water billing server of the municipality of Hinatilan, Cebu. Currently, the meter reading is done manually, where field workers visit each water consumer's vicinity. After collecting these readings, office staff will encode them into the water billing server. Over this time, the process has been time-consuming and discrepancies were noted due to human errors. So as a solution, this study hoped to automate the manual water meter reading and water consumption data encoding to the system through the use of sensors, IoT, and blockchain. In the current model, the water meter reading is done manually, and the collected data is encoded to the water billing server manually. So in the solution that uses sensors, IoT, and blockchain, water consumption data is collected and transmitted automatically to the blockchain network. The water billing server with added blockchain functionality will periodically retrieve water consumption data from the blockchain network. So these are the data stored and managed by the smart contract code in the blockchain. We have the water meter ID, the timestamp, the status, and the owner of the update. So for this project, YFS201 is used to detect and send signals for water flow volume. It interfaces with ESP8266 to measure the water flow volume. After acquiring the water consumption data, it transmits the data to the blockchain network using REST API. The water billing server queries for water consumption data from the blockchain network through REST API as well. So the study produced a significant efficiency improvement after real-time collection of water consumption data became possible. The automated solution also improved accuracy as errors were eliminated. So as takeaways for this study, in cases of network downtime, ESP8266 can store data locally until network is restored, and smart contracts can be modified to handle missing data transmission, missing the transmission interval. So as a conclusion from this study, automatic water consumption data tracking is feasible through sensors, IoT, and blockchain, eliminating the delay in water consumption reading and avoiding errors when manually encoding water consumption data. So that would be all for my study, and thank you very much for your time.
Thank you, sir, for the nice presentation. Can you go to your last second slide before the takeaway?
This one, sir?
It is not visible. Can you share your screen? I think sharing got disabled.
Okay.
Yeah,
How
now
about
it is
now,
visible.
sir? Okay.
Yeah. So you have mentioned here manual reading or encoding greater than or equal to 0%. So
Yes.
are you trying to say that you achieved 100% accuracy?
Yes,
Above
sir,
one,
with
above one.
this one.
Yeah.
Yeah, because manual reading, for example, in our experience, water meter readers sometimes recorded wrong consumer consumption on a different water meter ID. So there's the discrepancy with the manual reading. And also in the office staff who are recording these water meter readings when forwarded to the office, sometimes there's human error in encoding these readings to the water server.
Okay. So that means your accuracy for the solution which you provided is 100% in that case for automated solution. Am I
Yes,
correct?
sir. Yes, sir.
Okay. So very nice work.
Thank you very much, sir.
Yeah.
I'll stop the sharing now.
Yes, sir.
Okay,
Yeah,
thank you,
thank
sir.
you so much for the presentation. Now, moving forward to the next one. We have Akash Mangaluru Ramananda with the paper title Improving Vehicle Dynamics in Road to Rig Testing by Integrating Model-Based Simulation and LSTM Predictions. Sir, you may begin with your presentation.
Thank you. I believe you can see my screen. Is my screen visible?
Yes, now it's visible.
Thank you. Firstly, I would like to extend my sincerest gratitude to the chair committee, Professor Shailas, and organizers, fellow presenters, and colleagues. I would like to present one of our research work with the title Improving Vehicle Dynamics in Road to Rig Testing by Integrating Model-Based Simulations and LSTM Predictions. Coming to the agenda, so we'll be discussing in detail about the problem definition, existing literature work, our proposed methodology, results, conclusion, and references. Coming to the problem definition and motivation, we have like in the realm of mechanical systems, component and system failures are evident. Sudden and unexpected failures are more evident. So in order to avoid this, vehicle and component testing is very much important. So with the main emphasis on in the automotive industry or testing, so these failures could affect the system very much, for an instance, like the performance of the vehicle or the complete breakdown of the system. So the recent innovation in this field have showed, for an instance, like model-based simulation, which is a mathematical driven model, has shown some promising results. However, in automotive industries, these models are unable to incorporate real world conditions. And the other method would be road to rig test rig or the test rig approach, So these testing approaches are significantly higher in cost, and it requires skilled labor, maintenance, and further testing procedures for accurate predictions of the real world. And also the possibilities are with condition monitoring, which could do a real-time evaluation of the system to identify the health of the system and thereby prevention of its sudden or uneven failures. With these three problem definitions, we would like to address or bridge the gap between the model-based simulation and the testing approach to bring an efficient condition monitoring system to prevent failures. So this is our main objective, further to generalize that these developed simulation models with this combined approach would be used for further analysis of the vehicle like slip, drive, slip effect, and driving resistance. So thereby it can reduce the complete cost and time. Seeing about the current state of the art, we have like segregated into model-based simulations, data-driven models, and what are the benefits of data-driven models. In the figure, we see that, in this figure, we see that how model-based simulation has been used in the complete product lifecycle management of the vehicle being developed from its initial stage to the final product. And multiple approaches of this have been also used, but with an emphasis on model-based simulation, we'll be speaking about the model-based method approach and its benefits. Further, we see a data-driven approach, and the flow diagram of the data-driven approach is depicted. So these have also served a lot in the industry of automotive, and the benefits of these data-driven models are component testing and predictive maintenance, performance testing, real-time fault detection, and digital twins. From the existing state of the art, defining our methodology is as depicted. One side we have the road to rig testing or the testing approach, and we have a MATLAB simulation. So once the MATLAB simulation is done, we have a comparison and validation to evaluate the results of what we have, like speed versus time, torque, and rotation speed. Further, we would also extend the research to performance analysis like slip effect and driving resistance, and also develop a machine learning model to predict acceleration based on the torque at the wheels. So we'll be discussing in detail about each of these points in the coming slides. Coming to the road to rig test rig, the road to rig test rig is as depicted here. So machine 1, machine 2, machine 3, and machine 4, which are respectively mounted to the wheels. And the test rig is capable of handling multiple vehicle testing and component testing approach. And the parameters of the vehicles are depicted below. Further coming to our MATLAB simulation, we have the main blocks segregated as driver, engine, gearbox, axle plus tire, and vehicle body. So the longitudinal driver uses the WLTP or the worldwide lightweight vehicle testing procedure, which is one of the standard reference that is used in most of the automotive industries to test the performance of the vehicle and multiple different applications. So we are also using a WLTP drive cycle, which is referenced to identify the behavior of the vehicle. And also the engine and the gearbox is a customized design considering the vehicle of the BMW X3 X Drive, and the transmission is as depicted of the vehicle. And the axle plus tire comprises of the magic tires block and central rear and front differentials, and the vehicle body is designed considering the specification of the vehicle as depicted in the table before. Once the simulation model is done, we make a comparison of its results with respect to from the testing with respect to the simulation. For the front wheels, we see the distribution are very clear. It is matching, while some of the peaks are not achieved in the simulation. Similarly, also on the rear wheels, we see there is some gap between the peaks, while the distribution is matching between the testing and the simulation. Further, to evaluate it more better, we use a box and whisker plot to identify the min, max, and median values, which gives us a better understanding about the values that is being generated from the simulation model in respect to the test rig. So here we see, as we discussed before, the peaks are not matching. Also in the simulation data, there is some small shift. So the simulation model needs to have some improvement. However, we want to further validate it in our results. Extending it to a performance analysis where we see the slip effect of the vehicle at different road conditions. As we train them, as we develop the model in the simulation approach, considering depiction or the comparison for dry tarmac. Now we extended it for wet, snow, and ice tarmac to identify the vehicle slip on different road conditions. This is very much important to understand the behavior of the vehicle, its performance, and so on. Further, we also did the driving resistance calculation for the same different road conditions, and no much deviations are expected. So because the gradient or wind resistance are not that much calculated or considering the real world application. So that is also one of the drawback what we have to consider in this. Further, we trained the LSTM or the long short-term memory model from the simulation. We ran the simulation for data acquisition 3 times and took the torque at wheels, 4 different torques at wheels, and then used it to predict the acceleration, and the hyperparameters are shown below. Further, once the model is developed, we want to validate it, how accurate the predictions are. So we ran another test in our actual test setup on a WLTP drive cycle. And here we see the distributions of the data. So the peaks are matching, but the shift of the data is more evident, and also the variance or the shape of the data is not well matching, thereby showing that significant improvement is required in the simulation approach. The R-squared score also depicts the need of improvement. So to conclude our presentation, we would say that a comparison model was developed to bridge the gap between test rig setup and the simulation. The results depicted of 0.67 measures that there is a necessity of improvement between the torque prediction, and the scope of this work could also benefit virtual sensor conceptualization for test rigs. In our further approach, we want to validate this virtual sensor conceptualization for torque or the rotation speed, maybe the acceleration predictions, depending upon the application. We also want to do performance analysis like fuel consumption, efficiency, and thereby serving a good benefit to the automotive industries by reducing the cost, time, and possibility of bringing extended research facilities. So that was the presentation from our side, and these are the references and acknowledgement. So yeah, thank you. If you have any questions, I have me and my colleague Timo here. So we are happy to answer the questions. Thank you.
Thank you. It was really very nice presentation where you elaborated all the points of your research. Just one curious question after looking at your presentation. Since you showed some diagram on your slide, I don't remember the slide number, for front and rear wheels, right? So
Yes.
majorly we have 2-axle vehicles as of now. But nowadays, there are 4-axle vehicles also coming into market. So have you thought about the performance which is getting degraded on the rear wheels and not on the front wheels? So have you checked about it for the 4-axle vehicles also?
This is a 4-wheel drive which has a central differential where the central differential through central you have a rear and front differential. So in practice, that if the components everything is working fine, the transmission of motion has to be equally distributed to the wheels considering the rotation. If that is not happening, then there might be some error in the system, or there might be some requirement of improvement or some component changes. Yeah, to summarize it, like we have this vehicle done on a 4-wheel drive test. So
okay, and can you go to your slide number 18?
yeah.
So here there is a shift between your predicted and actual results, right?
Yeah.
And the results what are visible on the first image as well as in the second image, there is deviation. So have you done the analysis that on what basis this deviation might be?
Yes, this is our
Because
future scope because the test rig comprises of environmental conditions like wind, wind and other applications like the resistance offered and the tire modelings and so on. But the simulation model requires an improvement because these environmental and other conditions are not incorporated. And that is the reason, or that is our main objective for the upcoming days or in our further research, that we more focus on bringing these conditions to make an accurate prediction.
okay, thank you. That's all from my side.
Thank you.
Thank you so much for the presentation.
Thank you.
Moving forward to the next presenter, we have Varsha with the paper title Sentiment Analysis on Amazon Reviews Using Machine Learning Technique. Ma'am Varsha, if you're here, you can start your presentation. Still can't hear you. I guess there's some problem with the audio connection. Ma'am, you can reconnect your audio and meanwhile we can take the next presentation. Okay, so moving on to the next one, we have Jamol Joseph with the paper title The Vital Role of Additionality in Renewable Energy Generation for Sustainable Integration of Green Hydrogen Systematic Literature Review. Ma'am,
Hello,
you can
am
start
I
your
audible?
presentation. Yes, you're audible.
Thank you. Is my screen visible?
Yes, it's visible.
Thank you. So greetings to all. Myself, Jomo Joseph PDK. I'll be presenting today my paper, The Vital Role of Additionality in Renewable Energy Generation for Sustainable Integration of Green Hydrogen. This paper is a systematic literature review authored by myself and my thesis guides, Dr. M. Suresh and Dr. V. Ravi Kumar Pandey. We are gratefully thankful to the organizers of ISBM 2024 session chair and moderator for accepting our paper and also allowing us to present today evening during the conference. So in this presentation, I will commence with a brief introduction, explain about the problem statement that we attempted to analyze, explain the SLR methodology, the observations from the review, our contributions to solve our research questions, and conclude. So we are now all aware that our world is rapidly on a transition towards achieving a low carbon economy to tackle the climate change impacts. Numerous strategies and global collaborations have been set up in the present by all countries towards a responsible focus of cutting down greenhouse gas emissions by 43% by end of this decade, limiting global warming to 1.5 degrees centigrade. Presently, we know that the hydrogen energy has been the latest agenda towards a clean energy economy put forth by the Conference of Parties and targeted in all the global meetings to achieve this goal. Countries have set up ambitious targets to transit towards a clean hydrogen energy economy. And currently, but we know that hydrogen meets only 3% of the global energy demand, but it is expected to increase to 12% or with an optimistic prediction of 20% or higher. But currently in the 3% of that global energy demand that we are talking about, presently 95% of that hydrogen is gray hydrogen. It is produced from coal and natural gas obtained through steam methane reforming process. And the byproducts are carbon dioxide, carbon monoxide, and a little of methane also. Only 5% of hydrogen is presently being produced from clean and green methods, like which is being powered by renewable energy. So renewable energy is needed. So take one of these processes, especially like the water electrolysis, where current is passed through water, split it to get green hydrogen, water, and oxygen. So this green hydrogen can further be then consumed for other industrial processes or stored in fuel cells to generate energy when required. This versatile energy carrier actually supports many processes like electricity, heating, transportation, chemical, or even many other industrial processes also. So ever since the Paris Agreement and the COP26, in the past 4 to 5 years, there has been a significant research boom in green hydrogen. And there has been numerous studies and literature reviews which has focused in detail on green hydrogen production, the storage technologies adopted, and its socio-economic challenges. Though it might seem actually insignificant in the present scenario where green hydrogen produced globally is quite a very small percentage, we should definitely not overlook the contrary situation. Green hydrogen production needs renewable energy generation. can be from wind, solar, many other sources. And we are transitioning towards a clean energy economy through renewable energy sources. But a key concern needs to be also taken care of in this nascent state of green hydrogen. Will green hydrogen drive unsustainable use of renewable resources? That brings us to our research questions. How can we balance renewable energy use or green hydrogen production to prevent industries from unfairly consuming energy at the expense of other productive and domestic sectors? And how can we prevent industries from reverting to fossil fuel usage for the energy required in green hydrogen production? We conducted a systematic literature review, and the methodology was conducted in 3 steps: planning the review strategy, conducting the review, and then reporting and dissemination. From the 40 reports that we identified from the Scopus database, we narrowed it down to 37, then 32, and then 22, excluding the inaccessible documents, insufficient content, and less relevancy to the problem statement we have. These were some of the keywords that we used to find the documents from Scopus database, like green hydrogen, low carbon energy security, renewable energy scaling, and renewable energy growth. We can see that the timeline that I took was 2020 to 2024. This was chosen reflecting the surge in green hydrogen research following the Paris Agreement in 2015 and COP26 in 2021. And the subject areas were limited to energy, environment, engineering, social sciences, business, and management. And published versions of articles, conferences, videos, and book chapters were taken. So there was a paper distribution. If I look, though it started like around just 2 papers in 2021, it increased to 9 to 2023, and of course, we already in mid-time in 2024. This is likely to increase much, much higher than last year. So from all these observations that we went through the papers, we actually observed that the existing studies focused mainly on the challenges and potentiality of upscaling green hydrogen, international partnerships and cooperations for exchange of technology, resources and expertise exchange, that contributes to the upscaling of green hydrogen production. And studies on energy stability and security for integration of green hydrogen with renewable energy sources, which is basically variable and intermittent. Papers were also taken on national and international strategies to strengthen supply-demand chains and creation of demand security. But when we observed the entire literature that we collected, we felt that we observed that there was an overlooking aspect in challenges in expanding energy systems by integrating green hydrogen without adhering to the principle of additionality. So this brings us back to our research questions, which we initially mentioned. And we propose that there should be an essential requirement to adhere to the principle of additionality. So let me just briefly explain in the context of green hydrogen that principle of additionality here is basically the requirement of setting up additional renewable energy generation capacity exclusively for green hydrogen production. Because if we rely on existing capacities, that can challenge the use of fair access of clean energy to all, which can include all the domestic as well as the productive sectors. And further, if this continues, there also can be a tendency to fall back to the usage of fuel energy. So from this paper, we propose that it is very essential to actually prioritize the principle of additionality to bring in a balanced growth of green hydrogen that contributes to the green energy economy. And this thus would help in reverting to avoid reverting to fossil fuels, because sharing renewable energy between decarbonizing the grid and green hydrogen production would definitely tend to fall back to fossil fuel dependence. And if we can boost the renewable energy through this process, it would overall strengthen the energy balance and security to meet both the societal demands as well as green hydrogen growth. Market distortions can be avoided, as there would arise a gap between the renewable energy production and the energy demand, resisting the decarbonization efforts and lead to volatile energy markets. And of course, investing in additional renewable energy projects would definitely contribute to enhancing the climatic benefits, such as greenhouse gas reduction. So for promoting additionality and bringing it into practice, we suggest that there should be collective efforts or collaborative efforts from government and private sectors to provide incentives and subsidies of installation for new renewable energy projects. Robust policies and regulatory frameworks enforcing the principle of additionality will be required actually for fair upscaling of green hydrogen. And there should also be an enshrinement of global standards and certification schemes, which is needed to implement that verifies the additionality being practiced. International collaborations that enforces additionality should be encouraged and preferred for the sharing of resources, technology transfer, and expertise. Thus, I conclude that with the literature review that we studied, we felt that there were numerous studies which actually focused on renewable energy allocation and the effects of green hydrogen production. But we felt there was a lack of discussion on the additionality principle in this context. Thus, we propose that emphasizing additionality is vital to inform policymakers and raise a public awareness for a low carbon future. There would be an effective management of renewable energy if there is an allocation of our energy for both these sectors, that is power grids, and separately for green hydrogen. And this is very crucial to reduce the fossil fuel reliance and bring down the market instability. And if we go forward in that manner, there would be a well-planned renewable energy strategy, which is actually vital for a sustainable growth. Financial support that includes incentives and subsidies, promoting demand security, strong policies and regulatory frameworks will be needed, which is ensuring additionality and also technological advancements. This will be crucial for speeding up the green economy transition. And lastly, countries should commit to those international collaborations which has an emphasis on additionality that involves shared resources, technology transfer, and expertise exchange. Thank you. Thank you so much.
Thank you, ma'am, for such a wonderful, nice presentation. You have tried to provide a good renewable resource. So no questions from my side for your research topic.
Thank you. Thank you so much.
Thank you so much for the presentation. Moving on, I'd like to call Varsha. Are you like, do you?
I'm here.
Yeah.
Am I audible?
Yes, now you're audible. Okay. So yeah, you can begin with the paper now.
Yeah, just a
Okay.
minute. Is it visible?
Yes, it's visible.
Yeah. Good evening, everyone. I am excited to present our research on sentiment analysis of Amazon reviews using machine learning techniques. Throughout this presentation, we will cover how sentiment analysis can be used to interpret customer feedback. By analyzing reviews, we can identify trends in customer satisfaction, highlight key areas for improvement, and understand overall market sentiment toward a product or brand. These are the contents we are going to walk through this presentation. The problem statement is the objective
Can
of
you
this.
make it full screen presentation, please?
1 second, sir. Yeah. Thank you. Problem statement. The objective of the study is to leverage machine learning algorithms to analyze Amazon reviews and determine customer sentiments. Specifically, we aim to identify the best performing ML model for classifying reviews into positive, negative, and neutral categories. One of the primary challenges in this area is from the nature of the data itself. These reviews are often written in an informal tone with varying sentence structures and even spelling errors. These factors introduce noise into the dataset and make it harder to classify the sentiment. In addition, reviews may be ambiguous or contain mixed sentiments, adding further complexity to the classification task. For instance, A review might praise certain aspects of a product while criticizing others. From the business perspective, the impact of effective sentiment analysis cannot be overstated. It allows organizations to gain insights into customer opinions at scale. By automating this process, businesses can quickly and efficiently analyze large volumes of data, helping them make informed decisions regarding product development, marketing strategies, and customer service improvements. And here is the justification of Amazon review. These reviews were chosen for the study due to several reasons. Firstly, Amazon is one of the largest e-commerce platforms in the world with millions of users posting reviews daily. This makes it an excellent source of real-world data for our analysis. The diversity of reviews on Amazon also plays a crucial role in their suitability for sentiment analysis. Reviews span across a wide range of product categories from electronics to clothing to household, meaning that the dataset contains a wide variety of opinions and sentiments. This diversity enhances the robustness of any model trained on this data as it learns to generalize across different domains and types of products. From the business perspective, the value of analyzing Amazon reviews is clear. Businesses can use the insights gathered from this analysis to enhance their product offerings, improve customer satisfaction, and ultimately drive their sales. Moreover, understanding customer sentiments at scale can help companies anticipate trends, address complaints, and even identify opportunities for innovation based on customer feedback. This is the description of the dataset that we have considered. For this project, we used a dataset consisting of 2,500 reviews obtained from Kaggle. The dataset includes key features such as review title, review text, and review rating and other variables. The raw data had to undergo several pre-processing steps before it could be used for analysis. These steps were essential to transform the text data into a format that ML models could understand and process. Our pre-processing involved cleaning the text by removing punctuation, stop words, and we performed tokenization, which breaks the text down into individual words or tokens, which reduces words to their base forms. This ensures that, for example, the words like running and ran are both treated as the same root word run. Once the text data was cleaned and standardized, it was ready for feature extraction and modeling. Once the data was pre-processed, the next step was feature extraction. This is where we convert the clean textual data into a numerical format that machine learning algorithms can work with. For this project, we employed two techniques for feature extraction. One is count vectorizer and other is TF-IDF vectorizer. Count vectorizer, this technique converts the text data into a matrix of token counts. Essentially, it transforms each review into a set of features where each feature represents the frequency of a word in the review. Although this is a simple method, it does not account for the importance of words within the overall dataset. For instance, commonly used words may appear frequently but might not carry much significance. The next feature extraction method is TF-IDF vectorizer. This improves upon the count vectorizer by not only counting the word frequency, but also considering the rarity of the word across the dataset. Words that occur frequently in a single document, but rarely across the dataset, are given more weight. This helps reduce the influence of common words such as the and or, which occur frequently, but provide little value in determining the sentiment. TF-IDF is particularly useful when the goal is to highlight significant terms that distinguish one review from the other. Both of these methods were crucial in transforming our text data into structured numerical form, which was then passed to various machine learning models. In our research, we explored several machine learning models, each with its own strengths and weaknesses. First one is naive Bayes. This is a probabilistic model based on Bayes' theorem. It assumes that the features are independent of each other, which is why it is referred to as naive. It often performs surprisingly well for text classification tasks as it is both simple and computationally efficient. The next one is logistic regression. It is a linear model that estimates the probability of a binary outcome such as positive or negative sentiment using a logistic function. Logistic regression is widely used in text classification because of its simplicity and interpretability. It is particularly useful when the relationship between features and the outcome is linear. And the next one is SVM, support vector machine. This model is based on finding the optimal hyperplane that maximizes the margin between positive and negative reviews. It is known for its ability to handle high dimensional data, making it very well suited for text classification. By transforming the feature space, we can separate complex patterns and provide highly accurate predictions. And then random forest. It is an ensemble method that combines multiple decision trees to produce a more robust prediction. Each tree in the forest is trained on a random subset of data, and their results are averaged to produce the final prediction. Random forest is effective in reducing overfitting and improving model stability, particularly in cases where individual models may overfit to the data. NUSVM, this is a variation of the traditional SVM model where the NU parameter allows for better control over the number of support vectors and the margin of error. This added flexibility often results in improved performance, especially when fine-tuning the model to handle specific data characteristics. Each of these models has distinct characteristics, and we ran experiments to compare their performance in classifying sentiment from Amazon reviews. And performance measures. To evaluate the performance of the machine learning models, we used a set of key metrics that provide a holistic view of how well the models have performed. The first and foremost is the accuracy. This metric is the proportion of correct predictions made by the model out of the total number of predictions. It is a widely used metric. It may not always be the best measure in case of imbalanced data set. Then precision. It calculates how many of the positive predictions made by the model were actually correct. And then recall, how many of the actual positive predictions were instances were correctly identified by the model. F1 score is the harmonic mean of precision and recall, providing a single metric that balances both. These are the results of our model comparisons. Initially, we applied count vectorizer to extract features and used random forest and SVM models as our primary models. Interestingly, both models performed similarly in terms of accuracy, making it difficult to determine which was superior at this stage. So then we decided to use DFIDF vectorizer to see if we could improve our model performance by focusing on the importance of words in the dataset. However, the change did not yield significant improvements in accuracy. Recognizing that further tuning was necessary, we applied randomized search and fine-tuned the parameters to random forest, and we employed NUSVM to fine-tune the SVM model by introducing the NU parameter. After fine-tuning, the NU SVM model emerged as the most accurate, achieving an impressive 94% accuracy. This underscored the importance. I conclude that sentiment analysis on Amazon reviews offers valuable insights into customer opinions. These insights help businesses identify trends, address issues, and improve their product offerings. Through our presentation, we found that both random forest and SVM models performed well, but however, fine-tuning SVM with NU SVM resulted in highest accuracy of 94%, making it the most effective model for our sentiment analysis task. Discussing about the future scope, looking ahead, there are several ways in research can be extended. We could explore more advanced feature extraction methods such as GLOW to capture the conceptual meaning of words, which could lead to further improvements in model performance. Additionally, using deep learning models like LSTM or BERT could also help handle more complex sentence structures. These are the references. Thank you.
Very nice presentation given by you. So only one question from my side, that when you have tried to go for different method for doing the same task, that is doing the sentiment analysis on Amazon reviews. So have you gone through the features, like you told about tokenization, you did some tokenization in your data set while doing the data pre-processing. So have you gone through the various tokens that you got from the data set?
Actually, there were several attributes of our data set, but Yeah, we have analyzed other tokens as well, but we have found review title, review text, and rating. These are the most important and most effective tokens.
Because as your title suggests, it is a sentiment analysis. Somebody who is angry, he can give a good review. Somebody who is not angry, he can give an angry review. So you cannot do a sentiment analysis directly just depending upon the text, right? So
Yeah.
when you are working on that data set, whatever features are present in that data set, you told about some Kaggle. So have you done some analysis on the features which are present in that data set? Because applying different techniques, like you have mentioned in the future scope, you will go for different new techniques which can boost up the accuracy. That is fine. But
Yeah.
what if I want to improve the performance in the same algorithm? Have you thought about it?
No, actually.
Okay, okay, fine. Thank you.
Thank you, sir.
Thank you for the presentation. Now, moving on to the very first presenter who wasn't able to present then because of some network problem, I guess. So, Deepal Doshi, are you here in the session? I guess we don't have any of the co-authors or author of the paper here in the session. So, we'll be concluding the session now. Okay, so I sincerely thank all the authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, thank you for your support during this version and all the previous two versions of the conference. And we will be happy to have you in the fourth version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. So kindly cooperate with the team of ISBM 2024. I'd also like to thank our session chair for chairing this session. And here is a small token of appreciation on behalf of the team, Global Knowledge Research Foundation, and partners. Thank you so much for your presence,
Thank
sir.
you,
Would
ma'am.
you like to give closing remarks to all the participants?
Thank you, ma'am.
Okay, so yeah, at last I just request everyone to please switch on your cameras for a quick snapshot. Okay, thank you so much, everyone. Thank you. Have a great day.